You probably don't want to mess with the mantis shrimp. Its claws have inspired modern body armor, and it strikes with 1,500 newtons of force, despite being quite tiny, what you would need to bench press around 150 kilograms. That strike is so powerful that it creates an unusual effect, one that physicists still haven't quite figured out. When the claws snap, the motion creates small, hot bubbles that collapse to release a powerful shockwave and even produce a small pulse of light. It's called sonoluminescence. Researchers can create sonoluminescence in the lab to study how exactly these collapsing bubbles produce light and why they are so hot. Because these bubbles aren't just a little warm, they are about as hot as the surface of the sun. All it takes to produce sonoluminescence is sound with the right frequency moving through water. Sound waves are really just molecules that oscillate back and forth, creating areas of higher and lower pressure. When sound moves through water, the water can get pulled apart enough that the areas of low pressure create a small bubble of water vapor in a process called cavitation. Cavitation bubbles aren't like the regular bubbles you're used to. Regular bubbles are made by releasing gas underwater, like when you exhale. Cavitation creates bubbles because the very low pressure essentially tears a gap in the water. Some molecules quickly evaporate into the bubble, so it's not a vacuum or anything, but these bubbles do have much lower air pressure than a regular bubble, so they collapse. The walls of the bubble push the inside smaller and smaller, so the pressure begins to rapidly increase. There are a couple of ways that the bubbles collapsing could produce heat. One option is that as the pressure increases, so does the temperature, all the way up to several thousand degrees. But it's also possible that it's not just the increase in pressure. The gas inside the bubble might quickly turn back into liquid, which could also release a lot of heat. Either way, the collapse also helps explain why we see a flash of light, though again, physicists have come up with a few different possible explanations for what's happening. As the bubble gets hotter, different chemical reactions start taking place. Most of the molecules actually react with one another. These chemical reactions could be releasing a small burst of energy. For example, at high enough temperatures, water vapor dissociates, meaning energy is absorbed as the molecule is ripped apart into hydrogen and hydroxide. Then, when these parts recombine again, they release that energy. The light of sonoluminescence could be that released energy. Another possibility has to do with other substances inside the bubbles. If, say, argon is dissolved in the water, which it can be in seawater, then there might also be some argon inside the bubble. And the thing about argon is that it is very stable. It wouldn't react at all. So as the bubble started to collapse, everything would react except for argon. The argon would just get hotter and hotter, and some of this thermal energy might turn into light. There is some evidence to back this idea up. When scientists tried making cavitation bubbles in water that had extra argon dissolved inside, the light became longer and brighter. Yet another option is that the bubble has enough energy to cause some of the electrons to break free of their atoms. So the bubble ends up with negatively charged electrons separated from positively charged molecules. In other words, plasma. And when the charged particles vibrate, they release radiation, like light. So it's possible that the gas inside the bubble is briefly turning into plasma, releasing light, and then turning back into gas again. And the process of plasma turning back into gas could also cause energy to be released in the form of light. So there are plenty of possible explanations for how a collapsing bubble produces heat, and even more for how it produces light. This flash of light only lasts for about 10 billionths of a second, and it's hard to know for sure what's going on in that tiny fraction of a piece of time. But no matter how it happens, understanding a little bit more about sonoluminescence definitely makes me respect mantis shrimp more. Thanks for watching this episode of SciShow, which was brought to you by our patrons on Patreon. If you want to help support this show, help us keep making this stuff, learning about weird shrimp, you can go to patreon.com/scishow, and don't forget to go to youtube.com/scishow and subscribe.